This is part 2 in the series of scaling in the cloud for Azure. This is the Azure solution, which is Azure virtual machine scale sets. And so what we're going to do is deploy the same solution that we've deployed in the other environments with a virtual machine scale set. And what they composes mostly of is we deploy Flask-based microservices on Azure VMs. We use CosmosDB as the document database to store the microservice data for our simple Flask-based microservices. Then we're going to create a VM image of that stuff with Packer and create an image that we can use. And then after we've built the Packer image, we go to configuring the virtual machine scale set, which is done by Terraform. And that's the part that's going to scale up the number of instances. Now, like the other examples, we have sort of a load test to go through. The number of instances that it start with are 2. That's the default instances. Then there's a minimum of 2 and a maximum of 4. And so what we have is some code configuration that scales up the number of instances. If it's over 60% CPU for a minute, it'll scale up an additional unit or an additional VM. If it's lower than 60% for 5 minutes, it'll scale down. And of course, the constraint being the min and max. So you'll never go below 2 and you'll never go below 4. Then after we're done with all that, we're going to simulate that with the stress command. We will clean up all our resources and be done with this process. So let's look at the infrastructure diagram for this. This is, somewhat similar to AWS, but we start off with a virtual network, and within that we've got 2 subnets. Now subnets work a little bit differently than Azure than AWS. The biggest difference is we've got one subnet here for the Flask instances, and it actually, within that one subnet, you can have instances in 2 availability zones. You can have multiple availability zones beyond 2, but the point being that in AWS, your subnets are tied to an availability zone, and subnets inside Azure are more grouped by application function rather than physical location. So once we do that, we have on the scale set on the front end, we have an application gateway, which is an application load balancer using HTTP. It's got a public IP address, and that's how you access it through the internet. And on the back end, it's connecting the CosmosDB data as a document database to store your data. The next part is there's some prerequisites, and there's a video Azure and Terraform easy setup that you might want to go to that goes through a very basic example that goes through all this. Now you need an Azure account. The Azure account, you need to upgrade it to pay as you go. The free account has some limitations as to where you can put in certain things, like Cosmos is only available in some regions and the application gateway is only available in some regions. So pay as you go. You still get the $200, but you don't have those limitations, so you need to do that. Then you need to do the AZ CLI, Terraform, and Packer. And again, there's a video that helps you go through that. So I'm assuming this is done. So what we want to do is copy this code here, and I'm going to check out that code in my Ubuntu development environment. Paste. We got the code, and what I'm going to do is there's a script in all my projects called checkenv, which will go through and validate all those commands that we talked about are there, and then the environment variables you need, and then finally it logs into Azure. So at this point, what we're going to do is we're going to run the build script. So I will start the build script. Apply as the build script. And so while it is doing that, I am going to go back to this takes about 15 minutes to run. So before we wait on that, let me just go over briefly the build. The build is divided into 3 phases. The first part builds the network configuration and the project resource group. It also builds the Bastion component, which we will use when we want to run the stress command. And then phase 2 builds the Flask services into a VM using Packer, and then places that image into the resource group created in phase 1. The final phase is phase 3, and that's where we actually create the VM scale set, and it uses the image created in phase 2 and sets the scaling policy, the entire go up with 60% over CPU, go down with less than 60% CPU. So that is it for the sort of the phases of the build. So we'll go back here, and it's like I said, it takes 10-15 minutes. Okay, the build has completed. The validate script ran, which show everything up and running. And so what I'm going to do is I'm going to take this URL, which is the health check URL. I'm going to copy that and then open it up in a browser. And you should see the modified connect. Then when I hit refresh, 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 you'll see it's bouncing between. This is a load balancer, and it's load balancing between those two instances. So there's two instances deployed, and this clearly shows the load balancer working. So what we'll do is we will go in and let's just tour the build output in the Azure console. So I'm going to go into Azure, click on Home. I'm at the Home already. And what I'm going to do is click on Resource Groups. And this project creates the Flask VMSS resource group. And what we'll do is we'll walk through the elements that are created. So we'll start at the basics. The basics is the network. There is a virtual network that we created, and it's got 3 subnets. The first subnet is the application gateway. You have to have its own. The application gateway load balancer has to have its own subnet. Then there's a subnet for the EC2 instances. And then there's a third subnet, which is the Azure Bastion subnet. And we'll show Azure when we do the stress test. That's how we'll log into the boxes. The Bastion allows you to connect to an SSH session in your deployed instances once they are up and running without having to use a external SSH account. It'll just allow you to connect from the console. So we'll see that when we do that. So that's it for the networking. The Flask image that was built from Packer right there. And then we go back. Then sort of the main event is this virtual machine scale set object. So we'll click on that, and we'll see that we have 2 instances running. And if you go to scaling, what it'll show is there's a couple of values here. Here's the 60% issue where it will scale up if it's above 60% and scale down if it's below 60%. Of course, it takes 5 minutes for it to scale down. And then we have the minimum of 2, the maximum of 4, and default of 2. But you also have instant count of 2. And this is one of the differences between I guess AWS. They have this desired concept, and so they have minimum, maximum, and desired. It seems like that desired is a little bit different here, or it's a little bit different where default tells you the number of instances at the beginning, and then this is what the current instance count is based on scaling. So they've separated the defaults and the current setting, whereas AWS has kind of combined them. It's relatively minor, but first time you look at it, you're kind of scratching your head. It's like, what's the difference here? And it's just they've defined things a little bit differently. So we're also want to look at health and repair, and you'll see that there's a health check. The servers are actually running on port 8000. We've got the good to go endpoint, which is the health check. Then we also have recovery on, which means that if one of these things go unhealthy, if it's not responding on port 8000 for a certain period of time, that instance will be taken out and replaced. So this is also available on all the cloud providers where we have this, automatic repairs or self-healing if something goes wrong. So that's it for the scale set. What we're going to do later is trigger some of these scaling rules so you can see it go up and down. But for now, we've defaulted. We've got 2, 4, and 2. So let's go back to the resource group and let's look at, of course, we've got some network security groups in here. Like that one, the Flask one does 22 and 8000, so that's on the instances. Then you've got the gateway and the security group, which is port 80. That's the default port for the load balancer. And then you've got this bank of ports you've got to update in Azure so that the application load balancer will work. There's some restricted ports that it uses. It has to be open. So back, got the Flask app gateway. This is the actual load balancer. It's got some nice graphs here. Important thing is it's up at 2. If we go and look at backend health, you can see the backends, the ones we've been doing the load balancing test earlier, are running and they have a healthy, so 2 out of 2. So that's it for the load balancer. The last thing I'll show you is the candidates table. This is the table that contains the microservice data. So we're going to go and click on Data Explorer and candidates, items, and you'll see the items here. So John Smith, you're going to see that again when we run the Postman activity. You should see the additional ones. But that's pretty much it. There's this Bastion thing, which is included in the project, and they're pretty standard if you want to access your machines via the console. So we'll use that when we do the stress. And I believe we've covered everything that has gotten built. Okay, to test in Postman, what you want to do is go back to your development environment and run your validate script. And let it sit here and check. Make sure everything's back end healthy. And once it's complete, it will show you what the actual health check endpoint is. So I'm going to copy this guy right here and bring up Postman. And in Postman, I'm going to paste in that and do send. And we're going to get the same thing we got in the web browser a little bit earlier. So I can hit send, 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 and you see it's bouncing between. So that's the health check, good to go. The other endpoints are candidates. And you can see there's only one. When we built the system, it added John Smith. So I can do candidate and put John. And it's going to come back and say, I don't know no John. So you have to present the actual thing. And it'll give you John Smith. So that's the candidates API, the candidate get API, and the good to go. The last one is the post candidate. And here I'm just going to add some new candidates. I'm going to do homie1, homie2, homie3, homie4, and homie5. And so then I can go back to the candidates, make sure you change it to get, and it should show you all of them. And just to back up, let's go back to the console. Let's bring up the candidates CosmosDB, click on Data Explorer, and there we have the candidates. Click on items, and now you've got John Smith and all the homies. Again, not the most exciting document database. So I think the next step is we are going to simulate a load. So we'll get started with that. Okay, so now we're going to run a load on the servers using the stress command. So what you want to do is bring back to your console and go to Flask VMSS and go to the instance, and let's go to the first instance. Let's click on it, and let's do connect Bastion. And I'm going to use from a local file the default user created in this is Azure user. And then I'm going to go in and select the key that we used. Then I'm going to connect. All right. Now I'm going to do top, and we had 0. So I'm going to do stress -c2 ampersand, and go to top, and you should see it's now at 100%. So what we're going to do is go back to the instances. We did that for the first one. Let's do it for the second one. And go to connect Bastion. And go back to local file, select a file, private, connect, and do the top, 0, stress, C2, ampersand, top. You should now see it at 100%. So we'll go back to here. We'll click on the VMSS instance. And now we got to wait for the CPU load to increase. Okay, while it's scaling up, we can go back to our VM scale set, and we can click on monitoring there, and let's do metrics. And then we collect CPU, percentage CPU. So that's the one we're looking at. So it's going to take a while for it to run, but this is the graph that we should see when it goes up to over 60%. It's currently tiny, 0.4%. So it takes a while for all the metrics to come in from the alarms. And we should see this go up to 60, and then we should be able to go look at the instances and see what happened. Okay, after a few moments, you're going to see the CPU spike in the monitoring page. So I'm at over 60%. So then I can go back to the scaling set object and look at instances, and you can see it now says there are 4 instances. So it detected that it needed more instances, it added them, and if I go check the load balancer, so if I go back to Sky here, resource scoop, application gateway, then you check the application gateway backend health, and you'll see that all 4 of them are now healthy. If I go to that good to go endpoint in the browser, you're going to see it bounces between the 3. So it is being properly bounces. So now at this point, what we're going to do is we're going to turn off all that. So we're going to quit on this guy, foreground, Control C. Now it should be back to 0. I can exit this guy here, close. Then I want to do the same thing here, quit, foreground, Control C, and top. You'll see it's now 0, hit quit, exit. So now we got to let it essentially settle and go back to what it was doing before. So after a while, we should see the CPU load to drop back down, and the VMS it's already started to drop down, but it's got to wait 5 minutes, and then once that 5 minutes is over, we should be back and only have 2 instances running. So we'll wait for that. Okay, so I've given the cluster time to settle, and it's settled back down. We're now back to about 11% CPU, so it's still settling a little bit. But we should be able to go into the instances and see now I've got 2. So it has basically bounced back those ones that we added because of the load, and we're back down to 2. And so again, we go to here, we hit refresh, you're just going to see two instances like what was before. So that is the tour of the solution. You know, you should be able to go and modify anything in this project and then rerun the apply script, and it will rebuild everything and redeploy it. So if you want to take this and make it your own, the project itself is a is a template, so you should be able to create new projects from this project if it's valuable for you to do that. So now at this point, what we want to do is, to be a good steward of your resources, you want to go ahead and destroy. So I'm going to destroy. This takes a while, and it's going to delete all the Packer images and do all that good stuff. But before we sign off here, I have some sort of Azure-specific things I'd like to go over. The first one is when we're looking at the console, and I guess I can do that now and go back to scaling, and you can see that there's four. No, well, I'm actually in the middle of destroying, so that wasn't the greatest plan there. But in the earlier video, when we talked about the desire versus default number of instances, you know, it has four different values for scaling. It has the instant count, the default count, the minimum, and maximum. And AWS really has two, or three. It just has min, max, and desired. So desired kind of takes the place of both default and instant count. So it's a little bit different. It's just how they conceptualized it. It works pretty much the same thing, but they're two different values. Of course, we talked about subnets working differently. In AWS, subnets, the drivers for subnet segmentation is by availability zone. So if you want to make sure your subnets are across availability zones, that you have to choose your CIDR blocks and you do it that way. Whereas subnets inside of Azure and GCP can span multiple availability zones. So that's not the driver. The driver for creating subnets is either application needs or function. And of course, resource groups are another thing that's unique to Azure. They're just a key feature of how you interact with Azure. You know, I briefly did resource groups in AWS, and they're pretty janky and useless, but resource groups in Azure are really central to how you manage your resources. You can go and, monitor by resource group. You can track your costs by resource group. You can delete the resource group. You can assign RBAC roles on the resource group, so all your resources will inherit it. So Azure usually leverages the resource group concept, and it's quite useful. Then the final thing is the Bastion host is what you use for accessing SSH from the Cloud Console. This is sort of the equivalent of SSM inside of AWS. And GCP has something more like Bastion, but you don't actually have to deploy anything. So you have to do the Bastion host, you have to deploy a special subnet and a special sort of things, and then it just works. Whereas in GCP, it's much simpler. You just say, connect with the cloud client. I guess I lied. There's one other things here. Is the last thing is the application load balancers need to be in its own subnet. And so I guess they call it application gateway, the HTTP load balancer. You have to put that in a specific subnet, and there are specific firewall rules on the subnet. There's like a bank of ports in like the 65,000 range that you have to have open for the application gateway to work. So that's another sort of Azure-specific part of the setup.